Hi everyone, in this video we will quickly look at the average rate of change versus the instantaneous rate of change. Now let's start with the average rate of change. I'm sure you know that if you have a straight line on a Cartesian plane like this, that straight line has, of course, some kind of equation to it. mx plus c. That's not a nice x though. And especially the m here is of importance because that's the slope, also known as the gradient. And it tells us how much the value of y changes when the value of x changes. So that is the average rate of change. When I'm on the line somewhere and I would go to the right a certain amount, that's a change. Then I would go there to get on the line again, that's a change in y. We know that m is the change in y over the change in x. So rise over run. And the number that comes out is the average rate of change. So what we do is pick a point A on the line, pick a point B on the line, and we figure out the rise and the run and the gradient. And the gradient is the average rate of change. Now that's all good, but what if you don't have a straight line but you have a curve? That's where things get interesting. So now I'm going to show you a curve with GeoGebra. This is the curve of x squared. And I've got my 2 points A and B set out on the curve, and I can move them about. So now I'm going to say, okay, the average rate of change is still the gradient of the line between A and B. So that's the gradient of that line there. In this case, the gradient is 3.4. But if I move B up, the gradient changes. If I move B down, the gradient changes because the line between the 2 points change. And in fact, we can say, suppose A starts here and B is here. The average rate of change at this point is because A has a certain y coordinate, B has a certain y coordinate, and the difference between them is 0. So you might argue the average rate of change is 0, even though we know to get from point A to point B, we need to go down first, but then an equal amount up. So the average rate of change is not always a good way to describe how steep the function of x squared is. When I'm here and A and B are close together, it's not a problem. In this region, the function of x squared has a gradient of negative 5.7. Also, similarly, when I am here, in this region, the function of x squared has a gradient of around 4 on average. When I go here, the gradient is on average 1.7. Problems arrive when it's like this or like that. It's really an average rate of change. Now, the trick is to get the instantaneous rate of change. The instantaneous rate of change happens when B moves all the way over A, so it approaches A. Now what happens if I have 2 points that make a straight line and I move 1 point over the other? If I do that correctly there, B is exactly over A, there's no line anymore. Hence there's no gradient anymore. So that's a bit weird. So I can't take the average rate of change when B and A are the same point. As soon as B goes, I have an average rate of change again. So the trick is to take the limit. B approaches A, and we take the limit of that situation. So B actually never really gets there, but it gets really close. Like that. What is the limit situation? If B comes from the top or B comes from the bottom, but never really gets there. The limit situation is where b is actually on top of a, and what happens there is that you get the tangent to the curve. Now this tangent has a gradient, and that gradient in this single point on the curve. And that's called the instantaneous rate of change. So instead of having 2 points, average rate of change, I'm going to 1 point on the curve, instantaneous rate of change. But I need to find the gradient of the tangent. So the instantaneous rate of change is the gradient of the tangent to the curve at a point where x is a. So a certain point on the curve, there you draw the tangent, and then you find the gradient of the tangent. Now obviously we're going to do that in algebraic way and not with a picture. Now, how do you do it algebraically? The process is called finding the derivative. So derivation. So the derivative of a function tells you the gradient of the tangent curve of that function at a certain point x equals a. And now you can watch the other videos to see how we do that. Ciao!